Good day everyone. In this video I'll explain the solution to problem D of CodeForces round 972. We changed the problem at the very last moment, so ChatGPT couldn't solve it, and that is why I'm re-uploading just the solution for this problem. And this new version is actually much harder than what I explained in the previous video. So we have two arrays once again. And I would even say this is probably the hardest problem of the contest. Okay, so we have these two arrays. N is smaller than or equal to 2 times 10 to the power of 5. And the sum of all test cases is 5 times 10 to the power of 5. And once again, just like the previous version of that I explained, we can choose any segment, so some left endpoint and right endpoint, and swap AI with BI for all i's that are in between L and R. We can do this operation exactly once. In the initial version, we just needed to output, if we do this exactly once, what is the max GCD that we can achieve. So actually, sorry, max, like it's max, just the sums of GCD, right? So what is the maximum value of this? This is what we needed in the initial version. But this version also tells you count of distinct LRs that give you the max GCD. So you also need to output what L and R's can I choose, so that if I swap and count the value, I'll get the max GCD. Okay, let's see how we can solve this. Let's do divide and conquer. If you're not familiar with this algorithm, I would recommend you to check the algorithm first and then come back. So what we're gonna do is we have our two halves. This is gonna be a normal divide and conquer, by the way. We'll give our function the left endpoint, the right endpoint. It will split it into two halves, call the function for the first half, for the second half, and then try to merge it. So pretty much simple divide and conquer at the first part of the solution. So these two halves are actually going to give us like some max GCD. Let's call this one, and some CNT1. And the second one is going to give us max GCD2 and some CNT2. This is just the count of max GCD. Okay, so at first we can just understand what is the current answer, which we can do. Well, if max GCD1 is bigger than max GCD2, then we know that from the information we have currently, max GCD1 is the bigger one. So the current answer, this is not the final by the way, would be max GCD1 and CNT1. If max GCD2 was bigger than max GCD1, then it would have been max GCD2, CNT2. And if they are equal, it would have been that equal number, and the count would have been CNT1 plus CNT2. Right, so this part is pretty clear. Obviously, along the way, we need to keep track of what is the current max GCD and the count. Okay, so when we already know how to deal with this feedback that we received from both of the halves, now we need to understand how we can count the answer for points that, for like for ranges that contain in both halves, right? So the left endpoint is in the first half and the right is in the second. So how to count the answer for when we are swapping such segments. This is what we're left to do, because if the left and right endpoint are in the same half, like this for example, then we have already counted these answers when we're looking for the answer in this half. So the only thing left is to count all these answers, right? So let's try to understand how we can do it. Okay, here is what we'll do. We have our first array and our second array. We have divided both of this into two halves. Okay, first, let's go from left to right in the second half and keep what we get when we swap this part, right? So we just go from left to right, and obviously at any point we will have some segment here. When we move to the next one, we'll have this segment, and move to the next one, we'll have this segment. So at each point we have one segment. And we'll see what happens if we swap this segment with the array B. This is A, this is B. And what I mean by what happens is we know our suffix GCD. This means that we can actually get the entire GCD. So we can see actually if our swap is in the second half, what GCD we can get. And we only look for prefixes of the second half. So technically what I mean by this is it's not going to be a prefix, but for the second half it will be prefix. So there is some middle, and I will just fix the left endpoint to the middle, and the right endpoint will just move. And I will just see what GCD do I get in the second half if I change L to R at that current moment. And I'll keep all these values. This is basically what I was trying to say. Similarly, we'll go from right to left. And we'll keep again, once again, R will be fixed here, and L will just go to from right to left. And at each point, we will keep the GCD as well. Now, the way we're actually going to keep this is pretty important. Because as you see here, what we need to do is for each, like technically, once again, what was our goal? Our goal was to, we had some two halves, and our goal was to count all the answers that start in the first and end in the second. This was our goal. So in order to solve this, obviously the naive approach would have been to just say, okay, for this, I'll look all of the left parts, then I'll go here, I'll look all of the left part. So basically it will be n square, which is not good enough. But what we can do here is we can keep this is why we're keeping the GCDs, because we know that there are only gonna be log distinct GCDs. So we can keep GCD and some frag. This is a frequency. So how many times did this GCD appear in the second half when L is fixed to the middle and for R we just brute force on R. Right, and for the left half as well. For all the suffixes, so R is fixed and brute force on L, and just keep how many times you were able to get that specific GCD. And it's of course obvious to see that there are gonna be only log distinct GCDs, and here we'll have log 2. Let's call this GCD1 frag 1 and GCD2 frag 2. I talked in the previous video as well why it's only log. I mean, it's pretty simple. It just you have some first number, and the best case scenario is when you keep dividing it by 2. So we can actually just go all through all these values, and inside the loop we can go through these values as well, because they'll be just log square, which is fast enough. And remember, what this was actually is that here we kept all the suffixes of the first half, and here we kept all the prefixes of the second half. So basically what we can do is just we can for each pair we can just count the GCD of the two values and get the total GCD that we could have reached. And we also know how many times each of GCD appeared. So if this new GCD that we got by combining the suffix of the first half and the prefix of the second half is bigger than the previous, then we can update. If it's equal, we can just only update the count, and if it's smaller, then we don't do anything. And the overall time complexity will just be n times log square, which is fast enough. This is it for D. I hope this solution was a bit more clear. Our original solution, to be honest with you, was worse because we had to code it like during the last day, and our coordinator Scratch barely managed to finish it up. So we hope you liked the round. Feel free to leave questions if you have any. That's it for today, and hope to see you in our future rounds.